Now let's take a look at some of the information out of the calculations. Here in this first section we can see our volt drop levels. At each point we can see what the volt drop is going to be on each phase of our system. To the right hand side of this we can see any predicted neutral currents that have been calculated by the system. This will change and vary based upon various other factors defined in the final circuits further downstream. Below this we can see what our total kVA across our circuits is going to be. Here currently our total kVA is only based upon the fact that we have a load on our L1 phase. On our predefined, as you can see, when our kVA is spread across all three phases, our total kVA is expressed as three phase. Next we can see what our equities are within the system. Here, first of all, we have our design current, which is being matched against our protected device rating. As we can see from the information here, currently our design current is exceeding the device rating. The software, as a result, has popped up an error identifying the fact that our protected device needs to be larger in order to accommodate for our design current. Next we have our minimum IZ. This is telling us what the minimum size of our phase conductors must be in terms of the current carrying capacity. This information is calculated not only from our device rating but also any correction factors that we may have placed upon the system before calculating what our IT is. For instance, with our minimum IZ currently being at 6 because our protected device is a 6 amp device, if I go to our correction factors and make any changes for the ambient temperature, increasing this, you will see then our minimum IZ has now increased in order to take into account the fact that we have changed the correction factors around this particular circuit. Finally, this item here, which is IT, is expressing what the current carrying capacity of the cable currently selected in the system is. Here we have our impedance values, Z1, Z2 and Z1 plus Z2. Here our Z1 is expressing what our line conductors impedance are. Here Z2 is expressing the impedance of our circuit protective conductor. Finally, our Z1 plus Z2 is expressing the total impedance of the two conductors. Here we can see what the phase faults are for our current point in the system. Under the phase fault, here we can see what the maximum and minimum fault currents are going to be at our board. Over here to the right hand side of that, we can see what the maximum fault current is at the start point of our circuit. This will be at the upstream location at which our protected device will likely be installed at. Here we can see what our phase fault loop impedance will be. Here we have what the disconnection time of our device is going to be that is currently selected. This is then placed against our conductor withstand to ensure that our conductor will not be destroyed before the protected device operates. Finally, at the bottom here we have our earth fault levels. Our IAF here is referring to our earth fault rating at this point in the system. Our IA is referencing the current that will cause the operation of the protected device within the maximum permitted disconnection time of the device currently selected. To the right hand side of this we have our ZE for our external earth fault loop impedance for the earth fault at this point. Here we can see our disconnection time for the MCB against the maximum permitted in the particular part of the installation. Here being a distribution circuit on a TN system, we can see that the maximum is 5 and currently our protected device will disconnect in 0.01 of a second. To the right hand side of that, we can see what the calculated ZS is by the software, taking into account the impedance values that we saw above, and what the maximum permitted by the device currently selected. Here, the maximum ZS is currently based upon the generic data of the overcurrent protective device. It's worth noting that where we have manufacturer specific data, this information will be selected against the curve data provided by that manufacturer.